Hello guys, this is Fahad Mirza and I welcome you to my channel. Whenever I post a video about a model or a tool which requires a lot of GPU VRAM, people ask me in exasperation, is there any alternative of that? Every time that question pops up, and it pops up quite frequently, it reminds me of TPUs by Google. It really is quite cost efficient. The problem is that it is only available in Google Cloud. You can rent it, but you cannot own it. Google doesn't really make it publicly available for the public to buy it. Maybe there is no PCIe bus or something like that. But the fact of the matter is that unfortunately, we cannot buy it. But if you look at the high level and think about it, that is why there is such a crunch of these GPUs by Nvidia, and these companies like Google and few others, they are making it Nvidia to just monopolize the whole market. The purpose of this video is to just give you a glimpse of what this TPU is, and this is not by any means the marketing of the Google's TPU or anything like that. Rather, it is simply throwing a highlight on the fact that there are alternatives available. There is not a serious effort to put them to public, and this TPU is one of those. And in my opinion, TPUs are better than GPUs, and I will tell you shortly in very simple words why I am saying that. So let's first try to understand what exactly this TPU is. I will start with our good old CPU. So this diagram and all of these diagrams I have taken from Google's website, and I will drop the link to it in video's description. So this is a von Neumann architecture of CPU, which we are all aware of. So what CPU does, it loads the data from memory or values from memory. It performs some calculations on the values and stores the result back in memory for every calculation. Memory access is slow when compared to the calculation speed and can limit the total throughput of the CPUs. And this is what is called as a von Neumann bottleneck, and that is why when all of these gamers and some of the machine learning scientists, they were struggling to do their stuff on CPUs, and you have seen that happening whenever you're trying to get your models run on CPU, it just is sluggish or it just gets stuck. So that is where GPUs came into being, and this is a GPU in front of you. So to gain higher throughput, GPUs contain thousands of arithmetic logical units or ALUs in a single processor. A modern GPU normally contains around 3000 to 5000 ALUs. The large number of processors means you can execute thousands of multiplications and additions at the same time. This GPU architecture works quite well on applications with massive parallelism, such as matrix operation in a AI model or LLM. But GPU is still a general purpose processor. You can use it for AI purposes, for model running, training, inference. You can also use it for gaming. So it caters for diverse sort of application, which is not a bad thing. That is where Google entered and they created this TPU or tensor processing units. So Google designed this TPUs or cloud TPUs for their Google Cloud Platform or GCP as a matrix processor specialized for neural network workloads. TPUs cannot run word processors, by the way. They cannot control rocket engines or execute bank transactions, but they can handle massive matrix operations used in AI models at quite a fast speed. The primary task for TPU is matrix processing, and it is specially geared towards model training, inference, fine tuning, which is a combination of multiply and accumulate operations. TPUs contain thousands of multiply accumulators that are directly connected to each other to form a large physical matrix. And by the way, that is called as systolic array architecture. But I'm not going to go into further details of it. One interesting bit that has happened just, I think, a couple of days ago, or maybe still it is in pre-GA offering, is this the latest version of TPU, which is TPU V6e. Before I tell you about it, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, it is resilient, it is reusable, and it structures the output according to the shape of your query, and I will drop the link to their website in video's description. Okay, coming back to this new TPU V6e. So this is codename Trillium, and it represents the latest generation of these accelerators or TPUs. With a 256 chip footprint per pod, V6e shares similarities with its predecessor, which was V5e, but it offers significant enhancement. This has been optimized for text to image and text to video, and also their fine tuning. And there is a lot of notable features, including it has peak in-date compute, which is around 1836 tops per chip, which is huge. It has a sparse core feature. It has got 32 GB HBM capacity per chip, which is again huge. And every pod consists of 256 chips. It also supports training up to 256 chip, and then it even does the slicing in it. So as I promised you earlier, I'm not going to bore you with the detail of its architecture. You can read all about it, how many TBs it is doing, around bandwidth, around per chip, around capacity, and all that stuff. And I will drop the link to it in video's description. But the point remains that unfortunately this is locked into Google's own data centers. It is Google Cloud. We can't run it. We can't own it on our own local. So if you want to use it, you would have to use the Google Cloud. So yeah, so that is why Nvidia has this monopoly, unfortunately, that hopefully Google will rise up to the occasion, and maybe they can either open a subsidiary which could sell it to us. But yeah, and AMD is far behind, Intel is nowhere to be seen. So I think for the foreseeable future, we are stuck with this Nvidia's GPUs, and there will be shortage and there will be huge price tag on it. So that's it. Let me know your thoughts on these TPUs. If you have been using them in Google Cloud in GCP, let me know. What is your experience? Do you think it is worth renting them out from the Google's data centers or not? Or but one thing I have seen is that they are quite economical to rent. So if you compare a GPU renting versus TPU renting is far cheaper, but of course you are locked into Google and you can't move around, of course. So that's it. I hope that you enjoyed this perspective on TPUs. We need to be aware of all the options available. If you like the content, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share this among your network, as it helps a lot. Thank you for all the support. Thank you for watching.